Now let's look at another problem together. So now we're going to try to balance the equation consisting of zinc reacting with hydrochloric acid, HCl, to form zinc chloride and hydrogen gas. Okay, so here's our new equation. And so again, our first step is always to make that RAP table. That's what we're going to do first, right? Because we have to first figure out whether or not our equation is balanced, and our RAP table is going to allow us to easily determine that. And so again, in our RAP table, it consists of 3 columns. Okay, we label it RAP. And then in the atoms column, we write down which elements we're working with. Okay, so here we're working with zinc, Zn, hydrogen, H, and then finally chlorine. Those are the elements we see in this equation. Those are the elements we're working with. Those are the elements we're going to try to balance. And now we have to take inventory. We have to figure out how many atoms of each element we have in our reactants and how many atoms of each element we have in our products. And so we see Zn in our reactants to represent zinc. Well, whenever we see just the chemical symbol for an element, that tells us we just have one atom of that element. So we just have one zinc atom in our reactants. And now let's count up how many hydrogen atoms we have in our reactants. Well, again, we just see H here, so that tells us we have one hydrogen in our reactants. And then just Cl, okay, and hydrochloric acid, so that tells us we just have one chlorine atom in our reactants. Now let's look at our products. Again, we just see Zn here in this compound zinc chloride, so that tells us we just have one zinc atom in our products. And then we see Cl2. Well, that subscript 2 goes with the chlorine, so that means we have 2 chlorine atoms in our products. And then we also have H2. Okay, again, that subscript 2 tells us we have 2 hydrogen atoms in our products. And so looking at this RAP table, we can tell that our equation is not balanced. It is an imbalanced equation. We have not balanced it yet, so that's what we're going to have to work toward. We're going to try to get this equation balanced. And so looking at each specific atom, we can see that, yes, our zinc atoms are balanced, right? We have one zinc atom in the reactants, one in the products. But what's messing this equation up is that our hydrogen atoms and our chlorine atoms are not balanced, right? We have one hydrogen in the reactants, 2 hydrogen atoms in the products, 1 chlorine atom in the reactants, 2 in the products. So we're going to have to balance this equation, okay, to make all our atoms balance, specifically our hydrogen or chlorine atoms. And so we can just pick which one of those we want to balance first. Let's say we're going to balance our hydrogen atoms first. And so we have to think what number we can multiply the 1 hydrogen atom we have in our reactants by to make it equal the number of hydrogen atoms we have in our products. Right? We have 1 hydrogen in the reactants, 2 in the products. So what can we multiply that 1 hydrogen atom in the reactants by to make it equal to the number of hydrogen atoms we have in the products? And you're exactly right, right? We can multiply the 1 hydrogen atom in the reactants by 2, and then we'll have 2 hydrogen atoms on both sides of the equation. So now we'll have 2 hydrogens in our reactants and 2 in our products. And so this 2 here becomes our coefficient that we have to write up in our equation. And so we place this coefficient in front of the compound that contains hydrogen on the reactant side of the equation, right? Because we multiply this coefficient by our reactant hydrogens. And so that hydrogen-containing compound in our reactants is hydrochloric acid, HCl. So we're going to stick this coefficient 2 in front of HCl. So that's where that coefficient 2 goes, right? This 2 that we multiplied our hydrogen atoms by has to go in front of the compound in the equation that contains our hydrogen atoms, okay? Or at least our reactant hydrogen atoms, since we're only talking about the reactants right here. Great. And so let's rewrite our RAP table to see what changed here when we added this coefficient to our equation. So we'll rewrite our RAP table like this. Same format applies as always. And then again, our elements are zinc, hydrogen, and chlorine. We haven't changed anything about the number of zinc atoms we have on both sides. Okay, we still have 1 zinc in the reactants. 1 zinc atom in the products. But we did change the number of hydrogen atoms we have in our reactants. Right now we have 2H, or 2HCl. So that tells us that we have 2 hydrogen atoms in the reactants. And then we still have H2. And so that means we still have 2 hydrogen atoms in the products. Okay? So now our hydrogen atoms are balanced. We have 2 on both sides of the equation. So we're good with our hydrogens. Now let's look at our chlorine atoms. Right? So initially we only had 1 chlorine atom in the reactants. Now, okay, we place that coefficient 2 in front of the compound that not only contains hydrogen in our reactants, but also contains chlorine in our reactants. Okay? So we put this 2 in front of our compound that contains chlorine. And so now, since that 2 gets multiplied through that compound, we have 2 chlorines in our reactants, right? 2 multiplies through this compound, so now we have 2 chlorines in the reactants. And then we've always had 2 chlorines in the products, right, because of Cl2, and so that hasn't changed. And so now looking at this RAP table, we can see that our equation is in fact balanced, right? We have 2 hydrogen atoms in the reactants, 2 hydrogen atoms in the products, 2 chlorine atoms in the reactants, 2 chlorine atoms in the products, and then 1 zinc on both sides of our equation as well. So we have balanced this equation, and it is zinc plus 2HCl yields zinc chloride plus H2.